Hi everyone, welcome back. So this time we're going to be doing example 3.1 from your textbook. It looks something like this, and we're trying to find that resultant vector and that angle to the x-axis. Now, you're going to be doing the parallelogram method for this, so all we need to do is we need to make a parallelogram using these two vectors. You don't have to be great at drawing at this. Just remember that if you're not great at drawing, where it ends is probably not going to be correct, so don't use that for your signs. Okay, so once I've done that, I can go ahead and say that's 100 right there, that's 140, and I've got to figure out my angles. Well, I knew this angle 2 was 45 degrees, I knew this angle 1 was 30 degrees. So what else do I know? What else can I solve from this? Well, first off, I know that then the angle between these two, well, that's going to be 75 degrees, right? That's 75 degrees. Okay, so how does that help me? How does that help me at all? Does it help me? Maybe it's not helpful in the slightest. But I'm hoping it will be. I'm hoping it'll be a little bit helpful somewhere. So let's look around and see where that might help me. Okay, now if this angle right here is 75, then what is this angle right here? Well, let's think about it. That's 75 degrees, and if this is just another parallelogram that's the same shape, that should be 75 degrees, shouldn't it? Which means that this will be 180 minus 75. So this would be 105 degrees. Okay. Now if I know two sides of my triangle, and I have a 105 degrees angle here, I can solve quite a bit. This actually gives me quite a bit of information here. But is there anything else I can solve before going further? I don't think so. So what you would probably do here is I would use the law of cosines to solve for our side r. So c squared is equal to a squared plus b squared minus 2ab cosine of c. So I have my cosine of c from the 105 degrees. I know what a and b are. I should be able to solve for the resultant vector. That would be a good place to start. And then from that point on, I can start using the law of sines and the law of sines to solve for everything else. Now, I already have that typed out for us. So let's go ahead and check myself, make sure I did everything right. So alpha 1, okay, I found that I can find the angle phi right here. That came up to be 105 degrees, so far so good. And now we're going to use that law of cosines, like I said, to solve for it. So r will come out to be 192 pounds. I like that. Okay, so 192 pounds. Wonderful. Now, we remember that law of sines looks something like this. So we have our side A over sine of A is equal to side B over sine of the angle B, which is equal to side C over sine of the angle C. And so I know two of these. I know 105 and 192, and I know both side lengths. I just don't know their angles. So let's figure it out, why don't we? An angle I really want to figure out. Well, we'll leave it there for now, and then we'll come back to it in just a second. What I really want to find out is this angle. That angle right there. So that would be opposite the 100 side. So what I know is that 192 over sine of 105 should be equal to 100 over sine of some angle theta that I don't know. If you're wondering why I'm asking for this particular angle theta, it's because I know the length of this vector. What I don't know, however, is its angle to the x-axis. But if I know that this is 45 degrees right here, then I can say, well, that theta x is equal to 45 minus whatever this interior angle is. And so if I can subtract that off, I'll have theta x. So let's see if I did it right. And so I find, okay, well that looks pretty nice there. That's for the side AC. and that would be 44.8 degrees. And so in this one, at least, I did it from the opposite side. So 44.8 minus 30 is 14.8 degrees. So that is 14.8 degrees. Oh, a little bit too far. So we know the length now. This is 192. We know the angle. And hopefully, after seeing this problem done, you realize why I don't like the parallelogram method. I really don't want to bring in the law of cosines and the law of sines into every single problem. Now, there are places where this is the simplest way to solve a problem. Okay, it's the best way to solve a problem. But it's just those are few and very far between. So I would strongly suggest that you stick to the method of components. That's what I use in almost every problem I work. So it works for a bunch of forces, it's the better method. However, now you've seen how to use this. Now you see why we learned the law of cosines and the law of sines. But in all honesty, if you want to keep it simple, method of components is the best way to go. So, thanks for watching. I'll see y'all next time. Bye-bye.